Have you ever stared at a string of numbers with colons and thought, what in the world is this? Some kind of secret code? Well, today, you and I are going to crack it. We're going to pull back the curtain on mathematical proportions, and I'll show you that they're not some dry formula, but actually a really cool and surprisingly simple tool for making sense of the world.
So, here's our game plan for today. We'll start with the absolute basics, then we're going to uncover the one golden rule you need to know. After that, we'll use it to solve a few puzzles, see how it actually shows up in the real world, and then at the very end, I'm going to give you a challenge to try out yourself. Sound good? Let's dive in.
First things first, let's get comfortable with the language here. Before we can solve anything, we've got to understand what a proportion actually is and what all that strange-looking stuff on the page really means. Okay, so you see a statement like this, and yeah, it looks pretty intense. The way you read it out loud is 60 is to 105 as 84 is to 147. But forget that for a second. All this is really asking is a simple question. Is the relationship between the first two numbers the exact same as the relationship between the last two? That's it. And that's all a proportion is, really. It's just a statement, like an equation, that says two different ratios are actually equal. Think of it like a perfectly balanced scale. For this whole thing to be true, both sides have to have the same relationship. It's all about that balance. Let's put it another way. A ratio, that's just a single comparison, right? Like comparing 60 to 105. But a proportion, that's a bigger statement. It's saying that the comparison of 60 to 105 is exactly the same as the comparison of 84 to 147. You're basically comparing two comparisons.
All right, so now we know what we're looking at. So how do we solve them? Well, it turns out there's this one simple, really simple, golden rule that is the secret key to unlocking any proportion problem you will ever find. Now, before I show you the rule, we just need to know the names of the players. In any proportion like this, the two numbers on the very ends are called the extremes, and the two numbers kind of sandwiched in the middle, we call those the means. It's just some terminology, but trust me, it's about to become important. And here it is. This is it, the golden rule. In any true proportion, if you multiply the two outside numbers together, the extremes, their answer will always be equal to what you get when you multiply the two inside numbers, the means. It honestly feels like a magic trick. That's the whole secret. So let's test that crazy-looking statement from the beginning with our new rule. Okay, we multiply the extremes, 60 times 147, and that gives us 8,820. Now let's multiply the means, 105 times 84, and look at that, 8,820 again. They're a perfect match, so the code is cracked. It's a true proportion. Okay, checking if a proportion is true is pretty cool, but the real power of this golden rule is in finding a missing piece of the puzzle. So let's use it to solve one of those classic find X problems. And to keep things real, we're going to pull our next problem straight from the source material. This is from exercise 10B in the R.D. Sharma textbook. We're going to tackle a classic problem, find the value of X. Here we go. Here's our mission, right out of the book. 55 is to 11 as X is to 6. Our job is to figure out the one and only number that X can be to make this whole statement true and keep everything perfectly balanced. So just take a second to think about it. We have our golden rule, and we've got a missing piece. How do you think we put those two things together to figure out what X is? It's actually that simple. We just apply the rule. We know the product of the extremes, which is 55 times 6, has to be equal to the product of the means, which is 11 times X. And just like that, we have a simple little equation to solve. And from here on out, it's just a bit of simple algebra, right? 55 times 6 is 330. So if 330 equals 11 times X, we just need to divide 330 by 11. And boom, we find our missing piece. X equals 30. The scale is balanced. Look, this isn't just about finding X in a textbook. Proportions are everywhere, and they're a super important tool for just making sense of the world around us. Let's look at a really practical example. Okay, let's grab question 10 from our source. It's a classic word problem. You've got an electric pole casting a 20-meter shadow. Right next to it, there's a 6-meter tree casting an 8-meter shadow. So how tall is the pole? See, because the sun's at the same angle, the ratio of height to shadow is going to be the same for both. This is a proportion problem in disguise. You know, the best first step for any word problem is just to get organized. Seriously, laying out the info in a simple table like this makes the relationships we're dealing with crystal clear. You can see it all at a glance.
Okay, now we can take that neat little table and translate it directly into the language of proportions. There are a couple ways you could set this up, but one really logical way is to say that the pole's height is to the tree's height, as the pole's shadow is to the tree's shadow. And bam! Just like that, when we plug in the numbers, our real-world problem about trees and shadows has turned into that same old solve for x puzzle we just did. We've turned a story into an equation we know how to solve. And now we just unleash the golden rule one more time. The product of the extremes, x times 8, has to equal the product of the means, 6 times 20. So 8x equals 120. We divide 120 by 8, and we find out the electric pole is 15 meters tall. And we didn't even need a ladder. All right, you've seen what a proportion is, you've mastered the golden rule, and you've used it to find a missing number and even solve a real-world problem. Now, it is your turn. It's time to put your new code-cracking skills to the test. Okay, here it is, your final challenge, straight from question 9. The numbers 9, x, and 49 are in proportion. Your mission, should you choose to accept it, is to find the value of x. Just apply that golden rule. And hey, don't let the two x's in the middle throw you off. The rule works just the same. And that's pretty much it. You now have the key. You know how to crack the code of proportion. And what's cool is, once you start looking for them, you'll see these balanced relationships absolutely everywhere. In a recipe you're cooking, on a map you're reading, in the blueprints for a skyscraper. It's a basic language of how we build and measure our world. So the real question isn't just what will you solve next, it's what will you see differently now?